All right, let's begin moving our character around, and we're gonna pick on the level class for right now. We've not done anything with our update method. It's just been kind of hanging out down here at the bottom. What I'm gonna do is I'm gonna move this a little bit further up to the top because we're gonna spend a little bit of time there, and it's kind of one of the more important ones, I'd say. We'll put it over here with the contact listener. And the update method is, well, here it is. Look at this. Performs any scene-specific updates that need to occur before scene actions are evaluated. Do not call this method directly. It is called exactly once per frame. So as long as the scene is presented in view and is not paused, you can actually pause your scene if you need to. Your scene subclass should override this method. Blah, blah, blah. And by the way, if you did want to pause your scene, you can just go self paused. There it is, equals yes. But yeah, so the important thing is we're not going to call it ourselves, but oddly enough, we're going to use this update method to call updates on our characters. All right, because if our scene is running and not paused, then we want our characters to be running too. Does that make sense? If not, then you know, obviously we don't want characters running around if our main scene is paused. So here we go. One thing I'd like to do is put in here an NS log statement and just show you guys what the current time is. And here we go. All right, that's plenty of it. Let's grab our calculator, and so this is spitting out the time at, well, we can figure out the frame rate without even looking at it, but we're going to do that by taking one of those numbers. So let's paste this into our calculator, and then subtract the one before it, the previous time. So subtract that. Okay, that gave us 0.03. And let's just remember this number, so I'm just going to copy it, put it over here, 0.03. If the frame rate was running at 60 frames per second, that would be 1 divided by 60. Now look at this. We've got 0.016. Now, if we were to multiply that by 2, oh, look how close that number is right there, 0.033. So by multiplying it by 2, that implies that we would be running at 30 frames per second, not 60. All right, because let's try that again. 1 divided by 30 equals, there it is, 0.033. So that is an indication of the frame rate. And of course, we've been able to see the frame rates from the beginning here. We can just go over here to show FPS equals yes or no if you didn't want to see it. But how are we going to use that? Well, we don't actually need to use it. Okay, I'm just gonna rely on this update method to call the update methods inside of our characters as quick as it possibly can, and I'm not going to worry about anything if it skips a beat. Okay, and with my testing, you know, I'm kind of fairly confident that this runs okay, and let's just proceed. But I thought that was kind of interesting to kind of check out what the current time was. All right, so get rid of that log statement right there, and what we're going to do now is enumerate through all of our children. So we're going to say my world enumerate child nodes with name, and there's a few options here. You can put in the exact name, which is what are going to end up doing. We could also put a star right here, which is going to go through every child inside of my world, and keep in mind our background is inside of there too. So that's kind of not ideal for us, especially since we know our children have all been named with a character. And the other option you could do is put in here / character, and that would actually go through any sub-children of children or parents inside of my world and pick them out as well. We don't need to do that though, so just put in character and using block. Actually, let me just let that autofill in there, and now anytime it finds those children, let me finish this off. It's going to run the block of code that is inside of here. All right. So put a little note. It says do something if we find a character inside of my world. Now, for right now, I don't care if the character is a leader, if it's a follower, whatever it is. I do care, though, that I cast the node that we find, whatever that node is, as a CS character. Okay, so what I'm going to do is write character equals, and then I just put in here CS character followed by that pointer node. So all that's really happening here is I'm saying, listen, you found a node, all right, and if it finds that node, it basically just takes this, puts it inside of here. But at that point, it's just an SK node, all right, and what we're saying is, all right, if you find it, I know that it's going to be a CS character, so just make it equal to that. All right, so this equals that. Not a duplicate. I mean, it's not a, we're not creating two of them. They're now one and the same. But from here on out, my code's going to be all right with me making assumptions like, well, the one I'm about to make, which is now if I write in here character and I call one of my declared methods inside of this class, currently the only one I have is this create with dictionary. But I could do that. You know, I could write in here create with dictionary. You'll see that the code compiler fills that in because it knows that, hey, all right, that's a declared method of this class. That's not what I'm going to do, though. What I'm going to do is write update, and if we wanted to pass in the current time, we could. And well, if you know, do I want to do it or not? Let's just say update. Okay. And maybe we'll come back to that later. And let's do this, though. Just finish that off. So we'll come over here to our class now, and you're going to get this little warning that says, no visible at interface for CS character declares the selector update. That gets solved rather easily by just coming over here, writing void update. And of course then we need to put this inside of our implementation file somewhere. That's a pretty important one, so we'll just put it down here for right now. But we'll make a little note, pragma mark update. Alright, now let's put a little log statement that says update called on character. And we should actually see this 3 times per frame because we've got 3 of those characters on there, and it would make sense that it's going to find all 3 of them and call that particular method. So there we go. Update called on character, and here it is. It's running. By the way, I changed these to squares during the break. Just playing around. So yeah, that's a good sign. And now, just for the heck of it, let's try this. Let's put in here if self.paused equals a no. So we're going to kind of encapsulate that. And I wouldn't have thought that was necessary, but again, with some other testing, realized it was. And then let's go over here and pause the actual scene. So we'll just write in here 2 of these. Pause scene. Do that after a 4-second delay, and then after a 6-second delay we'll unpause it. So right over here, unpause scene, and then void pause scene. Okay, so we'll just write self.paused equals yes, self.paused equals no, and we're doing this, let's set the gravity down as well. -0.1. Now let's do 0.9. A little quicker. All right. Run it again. Here's our little army showing up. They're going to descend down, and they've stopped. Look. And they're going again. Okay. That's a very good sign. That's exactly what we wanted to have happened. Ironically, though, if I didn't have that that pause test right here, the gravity would have stopped. Here, I'll show it to you. The gravity does stop. I mean, the physics simulation stops. See, there's the pause, but look, this is still running. Ah, right? Weird. And that is definitely counter to what I just read right here. So long as the scene is presented in view and is not paused. Interesting. Okay. So let's stop that, and let's go ahead and set the gravity back to being at what it was before, at 0.0. And we don't need to run this any longer. We could leave those in, though. What the heck? Why not? All right, so let's head back over to our character class. Go up to the top, and let's put in here a couple new variables. This is going to be our speed, and the other one will be our current direction. And I'm making these short little int variables because, if you remember, well, for our direction, we only have 5 possibilities. 1, 2, 3, 4, 5. Yeah, 5 possibilities. And for the speed, you know, if something over 255 would just be absurdly fast for moving the character in tiny increments across the stage. So let's go back over here to the implementation file, and on both of these, what I'm going to do is set them up in the init statement. Speed is going to equal 5, and current direction is going to equal no direction. No direction at all. All right, now in this update method, come down here, let's get rid of that log statement. We are going to write our first switch statement for this project. And you can see as soon as you type switch, it begins to start to fill this in for you. Our expression that we're going to be testing is going to be the current direction, and one of our first cases will be if it happens to equal up. If so, then what we'll do is something right here, and that would be to write self.position. And we're affecting the entire self here, the entire class, not just the artwork inside of there. And we're going to put cg.make self.position.x would stay the same, and self.position.y is going to equal itself plus the speed. So our y-axis is going to be going up, and that's the only change that's going to be occurring here. Later on, we're going to put in a little bit of code for the members of the team that are not the leader, but for right now, this will work for us. And you know, one of the things I really like about the physics in this is that you can make changes to the x and y of the of your nodes, and you don't have to worry about always using the physics-based way of moving things, which is to apply an impulse or apply impulse and one other one. And we're going to end up looking at stuff like that later on, but just for our basic movement here, it just makes sense to use things like this, just affect the x and the y. So let's keep pasting these in here, and there we go. I'll leave us a little bit of room to add in some more things, and let's do one more here. Down, right. Oh, actually, I'll keep these in the same order as my notes. Right, And then for our last one here, we're going to put in no direction at all. And if that's the case, well, I suppose we don't need to run anything. So we'll make no changes. And I don't even really need to put that in there, but that's all right. And we can just put the default in here anyway, too. That's not going to do a thing. I guess I'll just, in case you do want to do something for no direction, leave that note in there. All right, down. We're going to subtract the speed. For left, we are going to subtract the speed, but we're going to do it from the x-axis. So minus speed, and then on this one. There we go. Okay, we shouldn't be seeing any changes right now because the only thing that's true would be our no direction. So nobody's going to be moving around. There's that message again. Springboard, whatever. We'll just have to quit the simulator. But we're going to change that in just a moment. So while the simulator's getting its act together, there we go. So nothing's going on. Nothing different. Let's put in our handlers for, and I'll put in a little pragma mark here. Handle movement. Okay, and these are also going to be ones that we need to declare, all right, because our level class is going to set each one of these anytime there's a change in movement. So when one of those gesture recognizers gets triggered, we're going to do something like move left with place. And this is going to be an NS number. I'd prefer that just to be an integer, but I'll explain why that's an NS number later on. And an NS number is an object. It's in our case, what we're going to end up doing is converting the number that we get in there back to a simple integer again. But again, you'll see why that is later. But what it refers to is the place is kind of your number in the line of followers. All right. And so we've got move left with place, move right with place, move down, move up. Okay. And later on we'll have things like stop moving, all sorts of other stuff. But this will do us plenty for right now. So go ahead and copy those, paste them over here, and let's just put in our opening and closing brackets instead of that semicolon. And just to keep things simple for right now, let's just put in here current direction equals left, current direction equals right, and you guessed it, I can just copy and paste this. Oh no, that's down, and this is going to be up. Okay, so let's go back over here to our level class, and we should put in here, let's find our, there they are, handle swipe left, and we are going to end up having to enumerate through all of our children again. And since we already have that code somewhere over here, it was up in our update statement, let's just go steal it. So we'll copy this part, go over here to handle swipe left, paste that in there, get rid of that. You know, it's interesting, I didn't think about doing this before, but I could also leave in that statement that to test if it's paused. I guess it, it's pretty harmless if we leave it out, because if it's paused anyway, you're not going to see a thing. So yeah, in this case, we are going to just again cast our node as the character, and in doing so, then we can write a character, move with place. And for right now, let's just put in here 0 for the place. Actually, you know what? Come to think of it, we can put in the place right here. And you might be wondering, well, how do we know what the place is? Let's do this. We're gonna create a little integer variable that we can use inside of the statement. It's we're gonna need to put block in front of this though, just so that we can use it inside of this block right here. Okay. And this can be an unsigned car, short little integer, call it place, and we'll make that equal to 0. And hopefully, there we go, all those problems go away. And now what we'll do is, after that occurs, right, place plus plus, so we'll increment that up 1. And this is sort of making one assumption right here, which is that our leader is going to be found first, and in this case the leader definitely is, and that's because the leader has been added first. And remember, I did talk about earlier that, or did I mention that yet? Well, let's not skip ahead too much. So anyway, this assumes that the leader is going to be first, and in which case he is going to be at the 0 placement or top of the line. And then for subsequent characters, they're just going to basically be 1 or 2, at least in this example. And we'll do something later on to really ensure that the leader is always the first one in here. But we're not really using this place anyway when we change the direction. So this actually should be working right now. Let's just give it a quick test. And of course, we can't move up or down or left or right. Oh no, or right or, yeah, up, down, or right. But we can move left, hopefully. Okay, there they go. Bye-bye, guys. Doom, doom. And they'll run into each other. Cool. All right. So I was about to say, let's go ahead and let's do this. We'll write in here if character equals leader. So we can put in there one little test, and could move that to right there. All right, kind of force that to be 0, and then we could put in else. Well, we can just put in an else statement. Okay, so if you're not the leader, you're someone else. All right. Let's just tighten that up a little bit, and we'll go ahead and use this same code for all these other ones. If you want to leave in the log statement, that's all right. We're just going to change this to move right with place. And move up. Move up. Okay, let's give it a shot here. Boink, boink, boink. Move up. There they go. Move this way. Moving down. Moving all over the place. And of course, everything is staying centered on this guy. There we go. Pretty cool, huh?